Hi everyone, we are set to continue our conversations on humidity, condensation, and clouds. If you missed the first video, please go back and look at that video in last week's setup, so for chapter 4. So we are going to continue with our work from that video, and that video talked about saturation and water vapor. And in talking about that, the big take home was that saturation is defined as the number of water molecules leaving a surface, and that is equal to the number of vapor molecules returning to the surface. And then you say that you have a saturated environment. You have a saturated atmosphere. And if you think about that number of water molecules leaving equaling the number of molecules returning, that brings us back to a very familiar law, and that is that equilibrium law that we were talking about in thermodynamics, where when we had high energy and low energy, though the high energy will move to the low energy to establish a balance or an equilibrium. Now we've got another episode of balance or equilibrium in meteorology, and you're going to see many of them. This is a recurring theme in meteorology, the search for balance. And here's our next one. It's in water molecules leaving a surface and returning to a surface. Of course, leaving a surface is evaporation, and returning to a surface is condensation. Especially when we put a cover over a cup, we develop a closed system that allows these rates of evaporation and condensation to equilibrate. So like I said, this is very similar to our second law of thermodynamics, which looks for equilibrium in energy, and this is just looking for equilibrium in the energy of water phases between ice and between water and between vapor. So let's look at that a little bit more closely, because you know that if you put an open cup of water in a dry room at room temperature, you know in a day or two that water will have evaporated into the room, and that water would have added vapor into the atmosphere of this dry room. Well, if we put a cover over that, we can start to really measure that water vapor more precisely. And in fact, this vapor here has a pressure that can push down on the water surface. And that sounds very familiar, like air pressure pushing down on a surface area. And you're right, it is very familiar, because this, instead of being air pressure, and air pressure would include nitrogen pressure and oxygen pressure and water vapor pressure and argon pressure. No, this is just vapor pressure that we're going to concentrate on. The pressure that's associated in this little closed atmosphere with the cover on top. We can make our own atmosphere above the water, and we can measure the vapor pressure. And we can measure the vapor pressure at different times. We can measure the vapor pressure when we first put the cover over and there's not very much vapor at all. We can measure the vapor pressure after a few minutes or after an hour or two. Or we can measure the vapor pressure over a longer period of time when there are equal rates of water evaporating off and water returning down and condensing back in. So we can look for different vapor pressures over time. Now you know that if you put this cup with the cover in a very cold room, you're going to get very low vapor pressures. And you know if you put this cup in a very hot room or out on a very hot picnic table on a hot day, you're going to get a lot more evaporation in here, and you're going to get higher vapor pressures. So these vapor pressures are dependent on temperature, but you know that because you observe these things, and it just makes sense to you. It makes logical sense. But let's put some math to it, because whenever we observe things, we put math to it, and that becomes what we call a scientific law. And here's the scientific law that talks about vapor pressure as a partial pressure. It's called Dalton's Law of partial pressures. And what it says is that the totality of all air pressure equals the pressure of nitrogen plus the pressure of oxygen plus the pressure of water vapor plus the pressure of argon plus the pressure of carbon dioxide plus the pressure of any other molecule that is in our air. And Dalton's law of partial pressures really works very well for our atmosphere by saying that we could measure just the pressure of water vapor in these closed systems. I mean, that vapor pressure exerts a force. Well, what does it exert a force on? Just on water, like lakes or oceans? No, we're going to use our vapor pressure to go back and talk about parcels again. Our imaginary models of air masses. And when you think about it, if we had a balloon, a parcel of air, filled up with air, we would have nitrogen and oxygen and carbon dioxide and water vapor in there. And here's my water vapor molecule. And there's my nitrogen, here's my oxygen molecule. My water vapor molecule exerts a partial pressure in the parcel. And it exerts this pressure on the surface of the parcel. The water vapor is pushing out the surface. Now remember, we learned that the warmer this parcel is, the more pressure all these molecules are going to exert on the surface. They're going to expand the surface. And we looked into that in Chapter 2 with expansional cooling. So warm air rises in its parcel. It really exerts itself on the surface of the parcel. It expands the parcel. It loses all of its energy because it works so hard, and it starts to cool, and that is expansional cooling due to some of these partial pressures that are reacting to the temperature of the parcel. Now, I want to stop there with vapor pressures, and I want to encourage you to go on and look at the next video and stick with me on these videos. If you go to YouTube and you search for vapor pressure videos, you're going to get the chemistry definitions of vapor pressure, which are different from the meteorological definitions of vapor pressure. So stick with me on this one. Remember, meteorology is a combination of chemistry and physics and a lot of biology, so the definitions can change. And I'm going to very, very slowly get you into the meteorological definitions, which will help you with humidity and will help you with dew points. See you on the next video.